So the next question is allocate minimum pages. This is our question for today, and I have written a similar problem that we have done earlier in this playlist only over here. I have copied this exactly from GFG. Over here 3 things are said in the question. I have just copied that, and what I have done is I have written equivalent points for the painter's partition problem. So let us have a read of the question. It says that we will be given with an array of integers and a k, value of k. This array of integer will represent, each integer will represent the number of pages present in a book. Okay, so there is a book of 12 pages, there is a book with 34 pages, and in this k we are given the number of students. So there are 4 books with a teacher, and that teacher will allocate the books to k number of students, and its objective is to minimize the maximum number of pages assigned to any student. So basically the load should be balanced between the k students, so that the student who is getting the maximum number of pages, that maximum I would try to minimize. That is our objective. And what are the constraints that are given? It is said that each student receives at least 1 book. So I cannot have a student who is not having any book, right? I should assign every student with at least 1 book. Like in the painter's partition problem, we had to assign each painter receives 1 board to paint. Now the second point is each student is assigned a contiguous sequence of books. So basically over here, if the books are something like that, you cannot give this book and this book to one student and the rest of the books to other student. You have to assign in contiguous fashion. Here also in painter's problem also we saw that the boards that are to be assigned to the painters, they were also in contiguous fashion. Then over here the third point is that no book is assigned to more than 1 student. Basically you cannot divide the book, you cannot tear the book and give half book to one student and rest half part to another student. That is also not possible, right? In painter's problem also, one painter would only paint the whole wall. We cannot divide the board and allow 2 painters or multiple painters to paint that board, right? That was not allowed. So it is exactly the same replica question, right? Only there are certain things that are changing. We will be discussing about them. Over here also we had to minimize the maximum size of board assigned to any painter. That was the question right there. Okay, so over here let me just tell you how the things are working. Over here, if this is the number of pages and we need to divide it among 2 students, then what are the possibilities? Okay, so what I was saying is this, I can assign this to student 1 and this to student 2. Now obviously I can see that student will have a lot of workload. Okay, then I can do what? I can assign this to student 1 and this to student 2, and this will be my maximum again. And I can also assign this to student 1 and this to student 2. In this case this will be the maximum. Now in these 3 cases I have to find the maximums of them, and then I have to return the minimum among these 3 maximums. So what I'll do is, in first case what I can do is 12 is on this side and student 2 has 34, 67 and 90. Okay, this is our case 1. Case 2 is 12 and 34 on this side, 67 and 90 on this side, right? After that 12, 34 and 67 over here, 90 on this side. Okay, now if I just sum them up, this will be maximum, this will be maximum and this will be maximum. Among these 3 maximum I need to find the minimum and return that. That would be our answer. As simple as that. Also this is the exact same case. These cases were also presented by painter's partition problem. Okay, no problem with that. But in case 2 over here, there is one special thing about this question. So what is this case? See, here there are 3 books and there are 5 students, right? So obviously this first condition, that each student receives at least 1 book, this condition will be violated because there are only 3 books. I cannot give half book to anyone. So this kind of cases I can directly check that if the size of my array n, if that is less than k, then I can directly return -1. Okay, in this case we have to return -1 if allocation is not possible. So this is a direct check which I can perform at the starting only, and we can return -1. So this is one difference, one single point of difference in this question over here. Otherwise all these concepts are pretty much same, right? We will be having a range. The range will be, basically you have to understand that this maximum page, this thickest book over here, this book is having the most number of pages. this book needs to be allocated to any one of the student. So I can tell that minimum 90 pages I need to allocate to any one of the students, and that should be the range of my answer. Should start from here, that at least 90 pages I have to give it to someone. So my answer will lie from 90 to, I have discussed in the previous question itself, to the sum of this whole thing. If k is 1, I would need to allocate this all the books to one particular student. There the number of pages will be the summation of all these elements, right? In brute force approach, linearly traveling through each of these pages, that I will be considering that 90 is the maximum allowed page that I will be assigning to any student, and based on that I would be calculating that if 90 is the maximum amount of page, then how many students do I need to allocate these books. If the number of students that we found are greater, then obviously I need to allocate more pages, because I have less number of students. I should distribute all the books among these students only. So this is exactly the same. I would highly recommend you to watch this problem. This is the part of the same playlist only. A couple of days earlier it was released. So yeah, that's it guys. I'll be just showing you the code enhancement. This was our painters partition problem. See, over here also ARR and K is also given. Over here also ARR and K is given. So I can just copy this thing. I can just copy paste over here. The only difference is that I need to check over here that if my n is less than k, I will be returning -1, right? And over here the variables I have taken as painters. I can do this as students. Okay, students. And guys, one more thing, over here I have discussed in the previous question that you should avoid this equals to sign, because we are not moving our max cap or n to mid -1, we are just moving it to mid. But as it turns out guys, if we change this to mid -1 also, then also the code works fine. I would just explain this thing and this bit, and I'll try to go ahead. See, so basically in the question of shipping a particular package within D days, in that question we discussed that the end should move to mid, because just take a moment and try to recap that we took this because if we found a mid for which we could shift the packages before the given amount of time, then we would not stop searching our solution, we would search the space ahead, because we are solving this particular issue, like we are shipping all the packages before the given number of days. So we are taking a maximum capacity of that boat. So maybe there is a possibility if we reduce the capacity, then we can take a little bit of more amount of days, because we are allowed to, because we were finding for this mid the number of days we found were less than the given amount of days, right? So that's why we did not change our mid to mid -1, because mid is also an answer, and we should not reduce our range to mid -1, because this is also an answer. But as it turns out that even if we do mid -1 guys, even if we move our n to mid -1, then if there are no other answers present in this prior part of the array, then in every iteration my start will move forward, and ultimately they will be referring to the same place. And now over here I have also put equals to in this while condition as well. So over here in this situation where start and end will be pointing to the same location, there will be another iteration, and obviously this capacity over here, if this is not the answer, then this will take more number of days. So if it takes more number of days, ultimately I will move my start to end +1. So ultimately again my start will point to the answer, which was mid only. If none of these are answers, it will again come to the first place, even if we change the end to mid -1, right? So that was another thing that I told you. So there is nothing wrong if you don't iterate till mid -1. That is also logically very correct. That is the scope of my answer, range of my answer. Why would I reduce that? So that is also not a mistake, right? Cool guys, let's just run this. Only this is the thing that I have. Okay, so painters, I should check students, right? Case 1 ran. Let's submit. Okay, so that's it. So basically this is the third question of the same type. We have done capacity to ship packages within D days, then the painters partition problem, and allocate minimum number of pages. So if someone is watching, I would highly recommend you to watch from the first question, which is capacity to ship within D days, right? Thank you guys, that's it.